want. That was just starting recording, so the class is recorded. Now, does anybody remember what we call the number that lives on the top of a fraction? Anybody? Starts with an N, has an R at the end, has numerator in the middle of it. Numerator, yes! Well done, class. Does anybody remember what we call the number on the bottom of the fraction? Well, I didn't get to do my joke because everybody knew. Starts with a D, ends with an R, and has a denominator in the middle of it. I do that joke a lot, Charlie, because it's funny. Quality jokes you continue to do, right? Huh? Well, that's hurtful. I think it was quality. You tell me a quality joke, Charlie. Oh, I see. So you know what quality jokes don't sound like, but you don't have a quality joke? I see. I'll tell you a quality joke. What's more believable than a talking dog? A spelling bee. It is a dad joke. All dad jokes are good. And technically, every joke I tell since I'm a dad is a dad joke. All right. Now, kids, which letter, X or Y, represents the part of the fraction? You got a 50-50 guess, kids. X, absolutely correct. X is the part, and Y is the whole. Now, we talked about pizza on Friday, yes? Because everyone's like, fractions are so hard. And then I said, I have a pizza in front of me. And then I asked, who would like a piece of my pizza? And I said, who would want half of it? And everybody was like, I know what half a pizza looks like. A pizza is a circle and you cut it in half. And yet they still tell me fractions are hard, right? Okay, so this pizza is cut in half. This is mine, Myers, and this half is who wants half my pizza? Jackson. So Jackson gets 1 out of 2. The whole pizza was 2. Jackson gets 1 of those 2 pieces. Easy peasy lemon squeezy, yeah? What if I cut that pizza in 4? Does Jackson still have this whole side? Yeah, because he's the only person that said he wanted any pizza, so I only have to split it with him. So now you can see that Jackson has, it's not 4. What's the denominator now? How many pieces is this pizza cut into? 4. And how many pieces does Jackson have? 2. What if I cut it into 8? Now how many? What is my denominator? 8. Because I've got 1, 2, 3, 4, 5, 6, 7, 8. And how many pieces does Jackson have? 4. And that explains why kids have trouble with fractions. Even though we change the numbers, they're the same amount, aren't they? Jackson still has this side of the pizza. And hopefully he didn't choose ham and pineapple, because that would make me mad. Is everybody good? Excellent. You all remember how we do fractions. Now, can I cut a whole thing into any amount of pieces that I want? Yes, I could. One time I used to work at a pizza place and my friend ordered a pizza. We cut that pizza into like 24 slices. So every slice was like this big. He called us up and said, that was a dicky thing to do. And we didn't care. The next time he ordered pizza, we cut it into 8 slices. But when we were making it, we pinched the dough in 2 spots and we poured like a whole bottle of red pepper flakes on the one section under the cheese. And then we cut it into normal. And he ate the pizza. And then he got to that piece. If any of you work in food, don't mess with people's food. It's really bad. But if it's your buddy, it's funny, right? Like you wouldn't want that slice of pizza. But if you were at the party and everybody took one slice and the one guy got the super hot slice, you'd laugh at him, right? Of course you would. It's like when someone falls down the stairs. You check if they're hurt, but then you laugh at them. Well, you're kids. You probably laugh first and then check if they were hurt. I was at a concert on the weekend and some guy was being a real dick. And he was bashing his way up to the front. And he shoved a bunch of people out of the way. And then when he got to the front, he fell over. Like on his face. So we were all like, dude, are you okay? And he was like, ah. And then we helped him up. And then we shoved him backwards. And he like, ah. But he was able to walk. So then we were all like, screw that guy. And went back to watching the concert. Anyways. This section is called adding and subtracting fractions. I'm going to remind you how to do it. And we're going to start with what you already know. What is 2 plus 3? This is not a trick question. I am not trying to fool you. What's 2 plus 3? Kids, I'm not joking. You all know 2 plus 3. You can get out your fingers if you need to. 1, 2, 3, 5. Right? Right. Now, let me ask you this. Are these numbers that I have written right here, are they actually fractions? Do they have a denominator that we do not write? Yes, they do. That is actually 2 over 1, 3 over 1, and 5 over 1. Do we all know that? If you didn't know it, you know it now. If you just write a number, it has a denominator of 1. Is everybody cool? All right, so now, you're smart kids. What do you notice about these 3 numbers? They're the same. And if those numbers are the same, then what did we do at the top? We just added them up, didn't we? So if the numbers are the same, we can just add the numerators, right? And you all already know this from grade 4, so I will remind you. If the denominators, is it okay if I just write den because I'm lazy? No, I'll write it out. If the denominators are the same, we add the numerators. Now, kids, are adding and subtracting the exact same thing? Yes, because subtraction is adding negatives, right? So anytime I say add, that automatically also means subtract. Right? We already know this. So let me ask you this. What is 1/5? I don't want to do 5. 1/3 plus 1/4. You have to ask yourself, are those the same? No, they are not. But we all remember that we can change how fractions look, can't we? And they still have the same value, right? Doesn't matter how many slices I cut this pizza into, Jackson is getting the pink part, right? if I cut it again, oops, that was a bad one. Now I've got 16 slices. He's still getting the same amount, isn't he? What do we do to change it? Well, what did we do to make 2 be 4? We multiplied it by 2. How do we make 4 8? We multiply it by 2. Fractions need both parts, don't they? And they're stuck together, right? So if you change one of them, you gotta change both of them. So I gotta multiply by 2 and by 2. So how can I make these numbers the same? All I do is multiply them together. What is 3 times 4? And if you can't do this in your head, you would use a calculator for it. Of course it is 12. Now you are intelligent young people. 3 multiplied by 4. So what does 3's numerator partner have to multiply by? Got to multiply by the same, 2 and 2. So here if I use 4, what am I putting here? 4. Why did you stop working? 4. And here I multiplied by 3. So what do I do with his partner? I multiply by 3. What is 4 times 1? It is not a trick question. 4 plus, what is, this one's a tough one, 3 times 1? Don't all answer at once. Let's give it some thought. I got 3 fingers and I'm only holding them up once. So that is 3. Now, do I have the same numerator? Do I have the same denominator? So what do I do with the numerator? Add it. What is 4 plus 3? 7 over 12. And that's done. And you all already know how to do that because you're in grade 10. You may have forgotten. That's okay. That's why I'm reminding you. Is everybody good? Excellent. Now, let's take a short break from math so I can find out, did anybody do anything cool on the weekend? I already told you I went to a concert of one of my favorite bands. They're super old. You don't know who they are. It's possible if your parents lived in Canada for the last 40 years, your parents might know who they are, but you don't. So you don't need to ask. You wouldn't even like them. However, I love them. I've seen them 35 times. My kids know them. My kid's first concert was them. My kid who's 21, his first concert when he was 19 was this band. My daughter's first concert when they turn 19 is going to be this band. But anyways, that's what I did. Did any of you do anything cool? None of you did anything cool? Oh, 5440. See, you don't know who they are, so it doesn't matter. Nobody did anything cool? Okay, without telling me, because I'm a grown-up, did anybody do something that was cool but they don't want to tell me because I'm a grown-up? At least do that. Or did you just lock yourselves in your basement and play Hollow Knight or whatever game you're playing right now? Did any of you make a TikTok video at Mill Lake? Nobody did a damn thing. You left here on Friday, went back to your rooms, locked the door, and didn't come out. Okay. Dustin, I noticed you laughed a little when I brought up Hollow Knight. Did you get the sequel to Hollow Knight? Oh, did you not play that the first time? Oh, Hollow Knight was a good game. I don't know what the sequel's called. It might be Hollow Knight 2. I don't know, my son got it and locked himself in his room, and I haven't seen him in days because he loves that game. All right, if everybody's that lame, break over. Let's do math. I would like for you to perform these calculations. 3/8 plus 2/8. You write down the answer. You will notice they have the same denominator. So we leave it as 8. 3 plus 2 is 5/8. Easy peasy lemon squeezy. Right? Didn't even need a calculator. 3 plus 2. 5. I got you. No problem. Yes? Okay. Let's see about this one. Maybe you need a calculator for this. Are you allowed to use a calculator in my classroom? Of course you are. Anytime you want. The denominator we do 31 plus 23. Now, Jackson, remember how you said, yeah, sometimes I push the wrong button on my calculator and then I write down the answer even if it's totally wrong, and then my teacher marks it wrong and said, why did you write that? And then you say, because my calculator said so. And I told you to remember the way to avoid that is to guess before you enter it. 31 is pretty close to 30, right? 23 is pretty close to 20, right? So the answer should be pretty close to 50, right? And when you write it down, you get 54 64ths. Now, here's the next thing that makes fractions difficult. Is that a right answer? Is 31 plus 23 54? Yes, it is. Was our denominator the same? Yes, it was. So is 54 over 64 a right answer? Yes, it is. But if you gave that answer to your grade 5 teacher, would she have marked it right? No, because you didn't simplify it. Or as your grade 5 teacher said, you didn't reduce it. I don't like that word. That's not the right word. So you are intelligent young people. You all saw I can make the numbers bigger by multiplying. Yes? So I must be able to make the numbers smaller by dividing. Can anybody tell me a number that I can use to divide that will work with 54 and 64? 2. I could divide 54 by 2, which would get 27. And then what would I have to do to 54's denominator? If I did divided by 2 to the numerator, I got to do divided by 2 to the denominator to get that. Now, I know that grade 5 teachers marked this one wrong because both of my kids had grade 5 teachers that marked it wrong. I am not that teacher. If you do some of the math right, you get credit. Does everyone understand? I hate it when people give you no credit when you do something that deserves credit. And I know that you won't tell me that it bothers you. It bothered you in grade 5 because nobody talks to me, and that's okay. I end up talking to myself all block. That's all right. But I know that you appreciate the fact that you will get plenty of credit if you do the math. Okay? Okay. So, now that we have talked about a couple of the weird things, I want you to do these two by yourself. Sorry, change that to 2/9 plus 1/3. You can work with the kid beside you. When I say by yourself, I mean I want you guys to do that without me doing it. Go. And if you finish that one, I'm going to put up another one. If you finish both of them, then you get to rest and chill out while we wait for me to show the answers. Talk to the kid beside you if you want. This is not a test. And if you need your calculators, go ahead and use them. I didn't show you an example like these because I want to see if people know the quicker way to do it than what I showed you. Okay. Are those the same number? No, one's 3 and one's 9. I need to make them the same number. Now you could do 9 times 3. But you also might remember, is there anything special about 3 and 9? When you're comparing them to each other. Remember, we're talking about multiplying and dividing, aren't we? Does anybody know? I'm sure somebody does. Pardon me? I know what you're trying to say, Charlie. If I do 3 times 3, I get 9, don't I? So if I multiplied that by 3, that would become 9. And then they would be the same number, wouldn't they? So I only need to put a 9 there. Did I change this 9? No. So do I change this 2? No. Did I change this 3? I multiplied it by 3. So what do I do to this 1? Same thing. So now I have 2 plus 3, which is 5 over 9. Is everybody good? Yeah or no, Harsh? What part? He multiplied 3 and 9? That works. Same way. If you multiplied 3 and 9, don't write this down, everyone. That got you 27, right? So then you multiplied 9 by 3. So you multiply 2 by 3 to get 6. Plus, you multiplied 3 by 9. So you multiply 1 by 9 to get 15 over 27, right? And that is right, like over here. But we want to make it smaller. So we divide by 3, we divide by 3. 15 divided by 3 is 5. 27 divided by 3 is 9. So you have the right answer. Okay? All right. So now, knowing that sometimes you only need to change one number, are those the same? No. Is there a good relationship between 5 and 15? Yeah. If I do 5 times 3, don't I get 15? Which means I have the same number, don't I? So, did I change this 15? No. So do I change 11? No. 11. Did I change this 5? Yeah, I multiplied it by 3. So what do I have to do to its partner, the numerator? The same thing. 11 plus 3, and that is 14 over 15. Is everybody good? Okay, 2 more practices before I give you something new. Nope. Yeah. So the first thing you check, as always, are they the same? No. And 5 and 3 don't work together like 15 and 5 and 3 and 9. So the easiest thing to do is multiply them. What's 5 times 3? So I put 15 there. What did I do to 5 to make 15? I times 3. So what do I do to 5's partner? Same thing. What's 2 times 3? 6 plus. What did I do to 3? I multiplied by 5. So what do I do to 3's partner? Multiply by 5. What's 5 times 1? 5. Are those 2 numbers that I can add above the same number? Yeah. What's 6 plus 5? 11 over 15. And you're doing the thing that the kids in calculus still say is the hardest thing in math. Is it? Calculus kids like, oh man, fraction's so hard. I think you're doing very well. So you got to do this last one by yourself. What color should I use? Anybody? Say a color. Blue? All right. Now, somebody give me a number between 1 and 10. 7. I'm going to go with 7/8 plus 1/12. And I'm going to hope that that works. That's too big. Let's erase it. Let's go with 2/3. There we go. That's an easier number to work with. What we did for E will work perfectly for F. I'm going to finish this question, then I'm going to show you the answer, and everybody who got it right is going to make my favorite sound ever in math class. You're going to go, yes. Because kids whisper the yes, and then they hold on to the S. So you keep working on it. How many people think they got it right? Only one person? If you got it right, will you do me a favor and go, yes, after? Okay, here we go. Is everybody ready? Yes. Now, kids, do you think if this was grade 5, Mrs. Bad Crumble, who was your grade 5 teacher, I know she wasn't really your grade 5 teacher, but Mrs. Bad Crumble is my nickname for all elementary school teachers. Because when I was a kid, every elementary school teacher I had was super duper old. And now they're younger. So, would she have marked this right? No, because she would have said, you're not allowed to have a numerator bigger than a denominator. And that is where we're going to come back in 2 minutes. You have 2 minutes to talk to yourselves, stretch, do what you need to do, have a brain break for 2 minutes. Go. This isn't allowed, right? Right? But it is allowed. Will this teacher mark that wrong? Would I get out my red pen and say, no, you kid, that's not right. I'm giving you 0. Isn't this a hell of a lot of math? Don't you deserve credit for doing math in math class? Of course you do. But you know that some kids are going to get A's and some kids are going to get B's, right? That's a B. If you want the A, you do what Mrs. Bad Crumble told you to do. How many 24s fit into 37? 1. How many 24s are there in 1? There's 24 of them. I need 37. This, if I use my little thinking brain, that is 24 24s, yes? But I need 37 of them. So how many are left over? What math do I do with 37 and 24 to find out what is going here? 13 is the answer, but what do I do? Right. I take my 37 and I minus my 24 to get 1 and 13 24ths. And this is a mixed numeral. And that's another word that I will be using all year. I need you to know what it is. Everybody cool? Yeah? Okay. So we're going to do 2 more practices, and then we're going to move on. Because you've all already done this, right? This is just reminding you. What color should I use? Orange? I don't have an orange. I'm going with pink. But he says orange and then he leaves. If I find an orange one, he won't even see me writing it. What a guy. All right. Somebody give me a number between 10 and 20. 17? Ooh, that's a tough one. So let's go with 17 sixths plus, let's go with 5 quarters. Now, would you be allowed to do 6 times 4 to find the denominator? You could. Is there a smaller one you could use? You can't go down. They've got to go up. So 6. What's 6 times 2? 12. Does 12 work with 4? Yeah, because it's 4 times what? 3. So I can use 12. So what did I multiply 6 by? 2. So what do I have to multiply 17 by? 2. If you can't do that in your head, you get out your good friend Mr. Calculator. 34. What did I multiply 4 by? 3. So what do I multiply his numerator by? 3. And 5 times 3 is 15. Do I have the same denominator now? So what do I do with the numerators? I add them. And what do I get? Can I stop there in Mr. Myers' class and still get a B? Yes. If I want the A, I would finish this off. How many 12s fit into 49? What math is that? That's division, right? 49 divided by 12 is 4. And then I think to myself, 4 is 48 over 12. How many 12s did I need? I needed 49 of them, yes? There is 48 of them. How many are left? 1. 1/12. That's a B. That's an A. Is everybody good? Yeah? Okay. Do this last one completely by yourself. I'm not going to say a word. Talk to the kid beside you if you need to. Let's go with 9/11 plus 7/3. Try it out. Talk to the kid beside you if you need to. Did we change 2? Yep. We multiplied it by 2. So what do I do to this 7? Same thing. 14 plus 7 gets me 21 over 4. Can I leave it like that in Mr. Myers' math class? Yes. Do you want an A? Then you have 5 1/4. Because 4 goes into 21 5 times and leaves us with 1 left over. Is everybody good? Okay, last one on adding before we go to multiply. Hardest one I can give you. Okay, this is the hardest question I could possibly give you in fractions for adding. If you can do even part of it, you're a rock star. Everybody good? Sorry. minus go. Who's going to be in charge of reminding me to start? You don't have to tell me the answer. What's the first thing you did? Hint, hint. It's the same as the first thing you did in I. What's the first thing you have to do? Jackson. Make it improper. Times plus. What's 5 times 4? What's 20 plus 1? 21 over 5. Minus. What's 3 times 1? Plus 2. Minus 5 over 3. What's my common denominator? 3 and 5 don't work together. 5 times 2 is 10. Do 3 and 10 work together? 5 times 3 is 15. Do 15 and 3 work together? Yeah, so we're using 15. Times, what did I multiply 5 by to get 15? 3. So what do I multiply 21 by? 3. What's 3 times 21? 63. What did I multiply 3 by? 5. So what do I multiply 5 by? 5. What's 5 times 5? So 63 minus 25. What's 63 minus 25? 38 over 15. Does that get you a B? But B's, come on, we want A's. So how many 15s go into 38? 2. And that leaves you with 8 over 15. Is everybody good? That is the hardest question I can give you in adding fractions. Because remember, subtracting is the same thing. So even if you didn't get the right answer, but you did part of it, are you in good shape? Yes, you are. It is 10:47. This block ends at 10:55. I'm going to give you the last 8 minutes off. Not enough people played the last game. It hurt my feelings. Oh, that reminds me. I was so busy having fun this weekend, I forgot to go buy gummy bears. So I'm going to pay, just like in the real world, I didn't make my deadline, so I'm going to pay a penalty. Everybody who I owe a gummy bear to gets 3 more gummy bears. So everyone on that list is going +3. Charlie, you can win gummy bears in my class by doing various things. It's funny, nobody wants to say their answers in notes, but then I say I will give you a gummy bear if you say your answer. And then all of a sudden everybody wants to say their answer. Even if it's wrong, they'll say their answer. Sometimes I'll say, if you even talk to me, I'll give you a gummy bear. Because I get so tired of asking, like, what's 5 plus 7? And hearing nothing.